All right, guys, welcome. Let's get started. First, a few announcements. Your next homework assignment is due on Tuesday of next week. That should be uploaded before 11 a.m. And then on Thursday of next week, we're going to have our first midterm exam. There's going to be two parts on that exam. The first part, your computer screens are going to be turned off, and you're just going to be solving some questions on paper using your Casio calculator. And then on the second part of the exam, you're going to need to turn the computer on and solve some questions using Excel. And then to submit that part of the exam, you're going to upload the files to MU Online. Now, the lecture that we'll have on Tuesday of next week is a review lecture. And so the coverage of that exam is including through the end of today's class. I won't present any new material in class on Tuesday. It'll just be some of the greatest hits on the stuff that we've had till now. And a chance for you to ask questions if you have persistent uncertainties on how to do a certain function on your calculator, on how to use Excel. As a reminder, all of our class lectures are posted as videos on YouTube, and the links for those are on MU Online. So you can review the entirety of every lecture we've had till now, and if you survived, then you'd probably be well prepared for the exam. And by the way, you know, with the YouTube, it'll actually allow you to play at more than 1 times speed. So you could play the lectures at 1.5 or 2 times speed, you know, and get through them really quick. So just an idea. Any questions about these announcements? All right. Today we are going to introduce some of the real power of Excel for optimization and for problem solving. Some really powerful tools called Goal Seek and Solver. And so to do that, open up your spreadsheet from Projectile Motion. Open up the spreadsheet from Projectile Motion. We're going to try and answer some questions using the analysis that you've already got set up. Because what you did last time was you created this graph of what the trajectory would be. And you also predicted X max, which is the range of the projectile. So for example, for a certain launch angle and a certain initial velocity, how far that projectile will travel. So let me get my spreadsheet from last time. Here it is, the projectile motion. So remember what we were doing was we were saying for some initial velocity, I'm going to highlight these in a different color today just because I'm going to be working with them a lot. So I'm going to be playing around with the initial velocity and then the launch angle. Let me do that in a different color just so it's easy to notice the difference. All right, so I'm going to play around with launch angle, initial velocity, and then we're going to be looking at the horizontal distance that gets traveled. All right. Okay, so back here in the lecture, what if the launch angle is 45 degrees and you want to have a range of 655? Then what initial velocity do you need? So what I'd like you to do is play around with the initial velocity on your spreadsheet, setting the launch angle to 45, and don't just type in 655 for X max. That's a calculated parameter. So let it calculate based on changing the initial velocity over and over and over many times until you find that your projectile range is 655. So in other words, back to the spreadsheet, what we're going to do is try our goal here. The goal is to have 655 for this horizontal distance traveled. When we've got 45-degree angle, play around with the velocity until this X max is equal to 655. And so 30 isn't going to do it. Is 40 going to do it? No, that's in the right direction. We're getting better, but still not high enough. So I'll pause the recording and give you a few minutes to play around with that and see if you can find exactly what is the perfect initial velocity that's required. Really repetitive, very tedious. You wouldn't want to have to do that every time, especially You know, like back in World War II, the Navy had computers, as they called them, on ships for finding firing solutions for their big 18-inch cannons, and it would take things into account like the wind speeds and the humidity and I guess probably the speed that the ship itself is traveling and their estimated speed and heading of their target, and it would take all this into account, and then it would tell their cannons which direction and what inclination to fire at. And so, I mean, you had to do it quickly, and this is not quick, and we're only playing around really with one parameter. We've only been playing around with the initial velocity. So imagine trying to, having updated data in real time for all those things like your ship's heading and so on. It'd be tricky to do quickly. And so there's got to be a different way than just changing this over and over until you get 80.15. And lo and behold, now we have approximately the right range. So one of the nice ways that we can solve this is if you go to the Data tab, there is this What If Analysis under Forecast. And so click on What If Analysis, and then we're going to use the Goal Seek tool. So I guess pretend like you don't already know the answer. Let's put this initial velocity back to 30. And we're going to see if we can, instead of typing that in ourselves over and over, What If Analysis, Goal Seek. And so here's our thing. We want to set cell, so we want to set cell C15, which is where we have the X max we're going for. So once we define that, you can click this button again and then type in the value 655 by changing, and now this is the cell that we're telling it has permission to modify over and over again. So we click on the location of the initial velocity, okay, by changing cell C6. And then I'm going to click OK, and as soon as I click OK, it's going to do the iteration rather than me having to do it. So it goes through in just less than a second and finds the solution should be 80.1595 meters per second. Yeah, let me repeat that one more time. So if you missed it the first time, I'm going to put in just this guess 10 meters per second. And so if you're on the Home tab, first of all, go to Data, What If Analysis, Goal Seek. And then there's two things we have to pick off of the spreadsheet. One is our target, and one is what it's going to change. And so Goal Seek, set the distance, X max, equal to 655 by changing the velocity, and click OK. And then it'll go and find the solution. It's very handy, right? So here's what I'd like you to do to practice that. Wait a minute. I thought I had some more of these. Yeah, all right, do this. Use Goal Seek to find out what if your angle has to be 30 degrees and you want to hit a target 400 meters away, then what initial velocity is required? Write that down and then make change, because the second question is what about 10 degrees in a range of 400? What initial velocity is required? And then the last one, you have a fixed velocity, but you're trying to solve for the unknown angle. All right? All right, so it's 67 meters per second approximately for the first one, 107 for the next. But then there's kind of an interesting thing, a quirk with the third question. That is that there are two possible launch angles that will get you the same range of 125 meters. You can either shoot at a steep angle and it will lob it high and then it will land, or you can shoot at a shallow angle and it'll go at a lower trajectory. And so there's two solutions, and which solution Goal Seek tells you depends on what number you were closer to when you started Goal Seek. So let me show you what I mean by that. Let me put in the question, this this one. All right, so we want to have, let's say we have a guess of 10 degrees, and we're shooting at 37 meters per second, and my goal, in this case, I want the X max to be 125. Okay, so I'm going to set up data, what if analysis, goal seek. All right, so I want the goal to be, it's 125, right? Yep. By changing the angle. Now my guess was 10. That was just the number that was in there at the beginning. So if I tell it to solve, then it will go and find the first solution, 31.8, because it starts at whatever number is there to begin with, and then it starts jumping around on either side of that number looking for a solution. And it stops when it comes to the first solution. But if I had like 80 degrees as my guess to begin with, and I do the same what-if analysis, so goal seek, and I'm going for the same objective for my range to be equal to 125 by changing the angle, now it's going to find the other answer. And so now it's stopped at 58.2 because my initial guess was closer to that one. So goal seek won't tell you all the possible solutions. It's called just like a numeric iteration. It's solving over and over again. It keeps changing the input until the output is equal to the goal. Any questions about that? Okay. Yes?
Whenever I tried doing the last one on mine,
Mm-hmm.
every time I would hit OK to find out it would say cell must have formula.
Well, it might be that you don't actually have the equation in, let's see, this X max. If it's not based on a formula, then it could give you the error message. You know, maybe at the end of class, I could take a look at that for you. Okay, so that's goal seek. There's an even better one though, even more powerful, and that is solver. Solver is more robust for a couple of different reasons. For one thing, you can control when it quits looking for the solution. Sometimes goal seek will quit before it actually should have quit. Like it'll get pretty close to the answer, but not exactly right on the answer. And in our case, it was close enough because our velocities were 37, 80, 80.1, and so on. But if you're working with very, very small numbers, like a very slow velocity in the hundredths or thousandths or 10,000ths of a decimal, then solver could think that it's close enough before actually we do. And so solver is more powerful. Most of you may not see solver right now. If you go to the data tab, you'll see what if analysis, but you may not see solver. Raise your hand if you already do have solver on your Excel. Nobody does. All right, so let me show you how to turn it on. Go to Excel and do File, Options, Add-ins, and then down here we're going to manage the add-ins, and so you'll click on the Go button. And then all you have to do is click the tick box here for solver add-in, and then it will show up on the data tab. Okay? Everybody have solver now? Great. Okay, so we've got solver. Now, let's try the same kind of problems. Instead of using the goal seek, let's use solver. So the 37 meters per second and 125 meters away. So this time with solver. So here's the same projectile motion, and I have my guess value of maybe 10 degrees, firing at 37 meters per second, and I want to find the X max that's 125. So the interface of Solver is a little bit more complicated. This time, it's got a lot more places for me to put information in. This is a fairly simple problem though. Our objective, I'm going to click on that and identify this range cell, so it's C15 because that's my objective. The value that I want is 125 meters by changing the angle. Okay. We'll talk about this other field in just a minute, subject to constraints. Down here in the options is where if I wanted to, I could tell it how precise it should be before it quits. You know, how many decimal points I want my answer accurate to. And so for this example, that's plenty of accuracy. So I'm not going to adjust that. I'll just stick with the default. So again, what I'm doing is my objective is for C15, which is the range, to be 125 by changing the variable of the angle. All right, so I'll click Solve, and it does the same kind of thing really quickly. It'll calculate some answer. It found the 31.8, and I can either keep the solver solution by clicking OK, or I can restore the original value before it did its optimization. So I'll just click OK. And the same thing as before. If my initial guess was 80, and I did solver this time, then let's make sure it's looking in the right cell. So C15 for the range. Our variable it can change is C5. So I'll click Solve. And it went and found the 58.2 degree solution. But let's say that we have that initial guess of 10. What if I knew that I didn't want to angle this cannon any higher than 45 degrees? I can add a constraint that's going to force it to pick out just one of those solutions. And so you see here where it says subject to the constraints. I'm going to click Add to add a constraint. And the constraint I'm going to tell it is that this angle, so cell reference C5, should be less than or equal to 45. So I'm excluding it from going and finding that other option. So I'm going to click OK to that constraint and have it solve. And it finds the answer is 31.8, even if my initial guess is that high one. Remember before when I said 80 is my initial guess, then it would find the second of the two solutions. But this time, now that I've got that constraint in, now that my constraint is that the angle has to be less than 45, even though my initial guess is the big one, at least I hope, it's not going to go find that 58 degree trajectory. Let's solve for it. And the solution that it found is the smaller of the two because of the constraint. So you can add an unlimited number of constraints. You can tell it, you can be really picky about what your solution looks like. And we'll have some more sophisticated constraints here in just a minute to illustrate that. Any concept questions related to Solver? Anything you don't understand about how it's working? All right. Here's a good example. Let's say that you have a company that makes 3 different things. Your company makes A, B, and C. And C is the most profitable thing. Obviously, with no constraints, what you'd tell your people to do is make as much C as possible, because that's the thing that gives you the most profit. Well, let's make it a little bit more interesting. What if you had the constraints of you had to make 300 units per day total, no more than 300. So that's exactly how many units per day you must make. You're required to make 50 of A to fill an existing order, 40 of B, and you can't make any more than 40 of C. And so 50 and 40 for A and B, those are minimums. And then there's a maximum constraint on C. So what we're going to do is we're going to find out, using Solver, what's the ideal number of things to make for each one of them. And so you can set up a new blank spreadsheet. And translate this table into the spreadsheet. So we've got a product, A, B, and C. And then this is the profit per unit, 13, 18, and 22. Okay. And just to make it clear what we're talking about, I'm going to highlight and format those cells as currency, reducing the cents with this button because I don't necessarily have to see those extra zeros. Now we're going to have a field where we find the number of units that we're actually going to make, and then we're going to have a column that says profit. So if we made one of each, then we would calculate the profit just, it's equals the number of units that you make times the profit per unit. And then we can drag that formula down, and then here I'm going to calculate the total profit. And so that will be the sum of these above it. Okay, so we've got our table set up here. Now we have to refer back to the constraints. What were the constraints again? We have to make 300 total. Let me copy and paste these onto the spreadsheet itself. All right, so here's our constraints. That's pretty big. $300 units per day is our total production that we have to do. Okay. $50 units per day of product A minimum, 40 units per day of product B minimum, and 40 units of C is the maximum. So what we can do using Solver is put in the constraints to tell us what's the best thing we should do. So go to Data, Solver. Now, our objective is for the profit to be maximum. So I'm going to set objective D9 to maximum by changing, and so now I'm going to highlight these number of units here. Oh, you know what? I do need one other field in here. I need a field that's the sum of the total units, because remember, we've got a restriction that we have to make 300. So I do need to have that in there. So this is the total number of units. All right. So let me go back in now that I've got that being calculated. Solver, our objective is for the profit to be maximized by changing these number of units, and then I'm going to add some constraints in here. So first of all, one constraint is that the total number of units have to equal 300. All right. I can add another one. I can add that product A, the number for product A should be equal to or greater than 50. Okay, I'm going to add another one that B should be greater than or equal to 40. And then the final one I'm going to add is that the number of units for product C should be less than or equal to, well actually, yeah, less than or equal to 40. Okay, so now here are all my constraints. There were four conditions that need to be met, and I've translated all four of those conditions into statements in the constraints. Everybody got your four constraints written in? That is C, we can't make any more than 40 units of C. All right, so now I'm going to click solve and see what it can do. What it's telling me is that the best case scenario, the best thing we can do is have 50 units of A, 210 units of B, 40 units of C. And if you think about it, it makes sense, right? Okay, so we want to make as much C as possible because it's the most profitable. So we're going to max out C at 40. And now we have to have at least 50 of A, but between A and B, which do we get more money from? We get more money from B. So we're just going to do the bare minimum of A and then put all of the rest leftover capacity into B. And so this solution that it went out and found just by iteration makes sense with what we kind of know intellectually, and that is that you have as much C as possible, as little A as possible, and put all of the rest into B. Okay, so we found that what you should be doing is 50 units of A, 210 units of B, and 40 units of C. And anything different than that is going to give you less profit. Okay? Now, there's the solution. Here's what I'd like you to do next. I'm going to hand this out, and if you've already got the previous one solved, this is a little bit more complicated. The idea here is that you've got 3 customers and you own 3 warehouses, and because of where the customers are located and because of where the warehouses are located, you have to spend a different amount on shipping for each one. So for example, if you send something to customer 1 from warehouse A, it costs you $40 to send that item. But if you sent that same item from warehouse C, it would only cost $24. So there are some constraints that are described here, and there's a starting file that you can use. It's available on MU Online. So go to MU Online and find the starting point for this one. It's got the costs, and then put in the constraints, which is that you have to send 200 items to each customer, but what we're trying to figure out is which warehouses should you send it from to minimize the shipping costs. So each customer needs 200 items, but warehouse A only has 100, warehouse B only has 200, and warehouse C has 300. So let me hand this out to you, and if you haven't been able to get the previous one successful, don't move on to this one yet. We'll try and figure out what the issue might be on the previous example. But this one that I'm handing you now is what you should upload at the end of class to get the attendance and participation credit for today. Does everybody have a copy of the solver activity? So what you need to do is put in some guess values for the number of units that you're going to have go from each warehouse to each customer. You can see I've just put 1, 1, 1 for each of these. These are input values that are numbers. But then down below it here, the total units received, that should be a formula. That's the sum of the columns above it. And the same thing, this total by warehouse. This total by warehouse should be the sum of the columns that are to the left of it. And then what we're trying to do, the objective here, as it mentions on the handout, is the objective is to minimize the total shipping costs. But there's the constraints. The constraints that we only have each customer wants to buy 200 items. Warehouse A has 100 available. So I'm going to just write this here as a reference. Okay, warehouse A has 100 available. Warehouse B has 200 available. And warehouse 3 has 300. And so these constraints you're going to have to put in using the solver. So I'm going to delete all these. And you need to set up the constraints so that we minimize the costs, that each customer is getting the 200 units that they want, and that you're not sending any more from each warehouse than actually are available. So when you first turn on Solver, be sure that you reset what it already has. Here in Solver, do the reset all to have the previous constraints blanked out. Okay, I'm going to do the whole thing from starting to end, from scratch. So if you're completely lost, follow along. If you feel like you're headed in the right track already, then you can just disregard what I'm doing. But I'm going to try and just show everything so that you can see all the steps. I'm just deleting some of these rows so that I can zoom in a little bit further. All right, so this is all given data. And we have to give it a guess to start with, and so I'm just going to say 1 unit from each warehouse as the starting point. Okay, so then these are the sum of the rows that are to the left of it, and then these total units are the sum of the columns above, because it's telling me this sum is how many units each customer has received, and this one is telling me how many each warehouse has sent out. And now the shipping costs are a little bit tedious to put in, but it's going to be the number of units from warehouse A times the shipping cost from that warehouse plus the number of units from B times the shipping cost from B plus the number of units from C times the shipping cost from C. And once I've got that typed in a single time, I can drag the formula to the right and it will apply it for the different customers. And then this field is the total of all of the shipping costs. So now this is where things get a little tricky. It's where I have to program in the constraints. So data, solver. Okay, so my objective is to have the lowest possible total shipping cost. So I want that to be minimized, so min. And for the changing the variable cells, I'm going to click this entire range because it can change all of those, any one of them. And the constraints are that, first of all, I know that each customer has to have 200. So I'm going to say this needs to be equal to 200. And then I'm going to add another one. This customer has to be equal to 200 units. And this customer has to have 200 units. Okay, so I've got that constraint down already. Now I need to add the limits of how much each warehouse can send out. And those limits are 100, 200, and 300. So add this total has to be equal to 100. This one has to be equal to 200. And the last one has to be equal to 300. Although we don't know exactly which customer they're all going to be sending their units to. Those are the totals that have to apply. So I think those are the only constraints. The number received by each customer and the number sent out by each warehouse. We know that we're minimizing the shipping costs, and the permission to change is this range of how many values. And so now when I click solve, that's the right answer. It should be the 26,000 is the minimum shipping cost, and then it tells us where each, how many should come from each warehouse to satisfy the customer requirements. So once you've solved that for yourself, save the file and then upload it to MU Online. There is an assignment that called 2/18. I think should be there for you to upload your assignment. Oh, 2/16. Yeah, right. That's today's date.